Hello everyone, welcome back to another session on private 5G. We have already recorded one on why enterprises need 5G, and in this session we will be focusing on the deployment strategy for 5G. And when I say 5G, like our discussions will be mainly towards private 5G, but more or less what I will be talking about in this lecture is applicable to 5G as well. But since we are focusing on private 5G, I will refer private 5G here and there, but those key principles, please remember, are applicable to 5G as well. And why we are talking about the deployment strategies, because whenever I see that the discussions around 5G happens, people normally see 5G as a silver bullet that can solve all of their connectivity requirements. So basically that can meet all of their connectivity requirements. So let's understand this with a very simple analogy. But before that, this session, again, like the previous one, I will not go at the nitty gritty technical details. This session is for the business leaders in the enterprise who have zero to very beginner level knowledge of 5G, and they are seeing that private 5G is there at the door, and they just want to understand this. And then this session is also targeted towards the network engineers who are beginners or enterprise engineers who have never worked on cellular technologies. So I am keeping it at a very high level so that I can connect with the audience. And now let's get into this. But before I start, let me give you a very simple analogy, and then we will come into the strategy, and I will connect the dots like why I was talking about this particular analogy. And what happened is that sometime back when I was in my native, there was another friend who was there working with me in a tier 1 city. He also went there, and what we were talking about is that he is looking for a new car. And there were some local friends as well there, and immediately, without getting too much into what my friend actually wanted, they bombarded him with the suggestions, and one of the top suggestions was that he should go with something like this, a Maruti car. This is a very popular brand here in India. And what happened is that they told that you will get all the services related requirements can be fulfilled here locally. You don't need to go out. If anything happens to your car, there is a local expertise. This is a very reliable car made for Indian roads. You can just trust it. But the problem here is that they were not listening to his requirements at all. What he wanted is that he was saving for a car for quite some time, and he wanted his car to be from a luxury segment which should meet some requirements. And he doesn't bother whether like there is a service station or not, because he was living in a tier 1 city like me, and there everything is available. But these localites, they just started talking about what they had seen, right? So eventually my friend bought something like this, a car from this segment. But why I have told you this story, because without understanding the use cases or without understanding his requirements, my local friends have directly jumped into the suggestions, and they just started giving him advices, whereas what they could have done is understand like what he exactly want, what is his budget, what are the requirements, what he is looking into a car, and then probably if they are capable enough they would have advised. And this is actually a very simple thing, but it still happens in most of the cases. And 5G is not different. When people talk about 5G, they say that, oh, as I was saying earlier, this is that silver bullet that can meet all the requirements. So go ahead and explain about it. But believe me, understanding the use cases influence the strategies, or how you actually deploy it or go for a particular technology. And that is actually true for 5G as well, right? So with that, what we will be talking about today, well, I had already given you a hint, but what we will be looking at is the deployment strategy for different 5G use cases. Is there any difference when we deploy private 5G in a network or 5G per se, right? Because some of these, as I was saying, is applicable to 5G as well. Is there any spectrum strategies that these enterprise business leaders should be aware of, right? So, and as usual, we will start with our high level first, and in that I will explain like where the bullet number 2 and 3 will fit in our discussion. So I will show you that, and then we will complete with the key takeaways. So that is very simple agenda. Only 2 points that I want to cover in this session. So let's just get into this. So let's just start with what makes a 5G network. If you had seen my sessions earlier, this is the picture that I normally start with so that I can tell you like where exactly or what part of the network we will be discussing in our session, right? So this is at a high level a 5G network looks like. So you have your UE, you have your radio access network where your radios, your towers are located. Then you have your core network, and the RAN to connect to the UE, you have a spectrum. For the mobile core to connect to the radio, you have this transport network, right? And when all these pieces that you see here are deployed for a single entity, as I was explaining in our first session, this called as private 5G, right? So you can assume at a very high level, private 5G is just, you can call it as a subset of a public 5G network, but that subset is dedicated for a particular entity. In our case, it is enterprise, right? So the deployment strategies that I'm talking, right, what we will be focusing on is one, this part, and then this part. How the different spectrum impact the strategy, and how the deployment of the core component of mobility affect a particular strategy or help us to beat a particular use case. So these are the two domains. This is first and this is second, that we will be focusing in our session today. But before that, before we get into the deployment strategy, let's understand the use case, and then we will deploy, or maybe we will talk about the design of a 5G network from the high level, considering those use cases in mind. Okay, all set? So let's just get into our discussion. So as with the 3GPP release 16, 17, right, there are three key use cases for 5G. The first one is enhanced mobile broadband, EMBB, where 5G talk about 10 to 20 Gbps of peak rate, 300 Mbps to all the users who are connected on 5G. If you talk about 4G, this is somewhere around 30 to 40 Mbps. So that is actually a significant number that you see here. And I'm not surprised that the traffic will increase manifold. And we are also talking about a support for high mobility, like somewhere around 5 kilometers per hour. When let's say you are moving into a bullet train, you should get a seamless connectivity. So this, our very first use case, the targeted segment for this is the end consumers, right? People like you and me, where if you want to download a movie with 5G, it can be downloaded within seconds or minutes, right? And in fact, like 5G is getting launched in different countries at this point. Some of the countries are ahead, some of them are in their journey. And I'm coming from India, and here, like me, if you have visited any of these service providers 5G experience centers, this is what they normally show there, that okay, you download this movie, you download this, you see what is your download speed. So this is what we promise you as a uh, 5G connectivity options, right? You can get a very very high speed, right? And this is as I was saying, mainly towards the consumers. The next use case is ultra reliable low latency communication, which is URLLC, where a latency of less than or equal to 1 millisecond is supported. And when I say 1 millisecond, it is actually from that radio tower to the end user. Let's say here is your UE. So this latency is 1 millisecond. If you recall my earlier diagram where there are multiple domains, right? Your radio tower is connected via a transport network to the core, and then maybe further. So your latency will increase. But here, when it says ultra responsive with the latency, that is 1 millisecond is this part only, right? It has to be very very reliable, because 1 millisecond, if you talk about the users, they don't need it. It is actually for the machines, it is actually for industrial 4.0, right? Where there are lots and lots of sensors connected on these machines, and they transmit the data, and they expect that the latency should be 1 millisecond and a reliable network, right? So this use case is actually targeted towards the industrial segment of the enterprises, right? Then we have the third use case, which is passive machine type communication, where within a smaller area there can be multiple of these devices, and they are connected on the 5G network. What 5G claims is that it can support 1 million devices in a per square kilometer of the range, right? That is MMTC. So this use case, if you see, is mainly addressed towards smart cities, right? Smart buildings, anything that starts with smart, where you have a lot of sensors in the building. The IoT side of the story basically fits in this use case, right? So you see there are three different use cases. EMBB, where your data rate is very high. Ultra reliable low latency, where your latency is very less, but my data is somewhere around low to medium only. And then it is a very dense network, but the data rate that you see, these sensors, right? You think about a IoT sensor, it might be transmitting the data in some kbps only, but then there are like thousands of such sensors when you enter on a building floor, right, doing different purposes. So three use cases, different use cases, I would say, right? So does 5G deliver all of these? That's where our discussions is for today, that these use cases do not mean, and I repeat, do not mean any 5G system will support all of these use cases. It actually depends, right? And that's what we will figure out how. So first, let's see the deployment strategy for the packet core, right? And again, I'm keeping it at a very high level. If you have no idea about how does a mobility packet core looks like, what is AMF, SMF, UPF, don't worry, we will not even use those terms, right? But still I will try my level best to explain the point, right? So those three use cases that we had just seen. Now let's see how the deployment strategy changes for them. So our first use case was enhanced mobile broadband, where we are talking about high data rates, somewhere around 10 to 20 Gbps, right? So this is our radio tower. We will take a very simple 50,000 feet view of a 5G network, right? And then these are my core components. When I say core component, is mobility core components, right? And what you see in orange here, this is like my control plane, and this is blue denotes the data plane. And I had still maintained this color coding scheme. So earlier in this slide, if you see, blue was for enhanced mobile broadband, right? So here in this use case, I know that the user expect higher bandwidth, right? So what I will do is I will deploy my control plane, I will deploy my data plane, and along with the data plane, I will have some compute servers, high capacity computes, where I can cache some of the data, or let's say movies or whatever these users are doing here, and then I can directly get the response from here itself, right? That way, my users, end users, will have a very good enhanced experience, and at the same time, these bandwidth intensive applications are not going further in my network. I'm addressing those at the edge itself, and then in 5G at a high level it is called as MEC, right? So on the edge itself, I am deploying this, and then I am serving that to my users nearby. Then if there is some other area comes, I will do the same thing, follow the same strategy, apply some more caching server there, and fulfill that requirement there itself, right? But if this is something that is not clear, right, let's look at the another use case and try the same analogy. So our next use case was low latency, right? So in case of low latency, where I have applications like automated guided vehicles or some sensors, right, in an industrial environment, what I will do is I will have my control plane as denoted by orange, so no difference here. This is my data plane, right? So what an SP, let's say there is a service provider who is providing this private 5G connectivity to this enterprise, where they are looking for this URLLC use case, right? So this service provider X, let's name this as X. So what our service provider X will do is he will deploy the control plane components like this, but then he will deploy these data plane components closer to this enterprise, right? It can be even deployed, this is data plane, right? This can be even deployed on a factory floor, right? So that I can meet my latency number of 1 to 5 millisecond, right? If the data plane is local, I am getting the response locally within that premises itself. Obviously, my latency is less. Think of it like for those of you who are coming from the pure networking background, doesn't have any wireless background. Let's assume that you have this chassis, right? This is it can be a Cisco router, it can be any other vendor router where there are this multiple line cards. So this is line card 1, this is line card 2, and this is your control plane. Let's say here your processor RP is sitting, right? So what happens is when there is a packet comes, like let's say a data plane packet, it hit on the line card 1, and if the destination is located on line card 1 itself, it will simply come out of another port only, right? It will not even go to the RP. Or if the line card is on a, or if the destination is on LC2, it will hit the back plane, which is like a fabric, and then it comes out via LC2. But the point here is it will not hit the RP. So this is my data plane, right? So that way I'm able to reduce the latency because I don't need to go to my CPU or RP, right? But then if it is a control plane where let's say there is some ARP resolution, right? That packet need to be, let me use a different color here. If there is a R packet, then that R packet LC1 will punt to the CPU, then the response comes, and then at a high level it will go right wherever it needs to. But you see the point here, right? It has to go to the CPU, right? But only the control plane. So that's where with the same analogy I am keeping my control plane here, right? So whenever these endpoints, or they are also called as UE in the mobility terms, comes online, they just register with it. But then for the data plane, it just comes locally via that factory floor. So that way I am able to meet the latency number. So if URLLC is my use case, this is the way I will deploy 5G. I will not use any of these systems, right? And let me clear this sync. Now, I hope this is clear, but then with the same thought process, let's look at the another use case, which was like massive machine to machine type communication, right? So in this case, as you see, there is a smart building, there is a smart city, right? Where there are so many of these endpoints located, right? So all of these endpoints, when they come online, they need to register, right? Because whenever, let's say in enterprise, if we talk about an AP, there is a AP and then there is a WLC, right? So once AP comes up, WLC sees that, right? So it's a wireless LAN controller. Same way, on the mobility side, when there are endpoints, right? When they are coming up, they need to register themselves with the control plane. But in this case, I have so many of such endpoints, right? In a smaller area, there are so many such small sensors, right? So what I will do is I will deploy a bigger control plane, as you see here with the size of the boxes, right? Here I try to depict that with more capacity as compared to here. So these are like provisioned with more capacity so that they can cater the demand of such high number of endpoints. But then remember what I said earlier, these endpoints are not generating that much data. Each of these may be generating just 1 kbps of data or 5 kbps of data, right? So for that, I can deploy a smaller data plane. So this is my data plane, right? So that way you see with each use case, how does the deployment of 5G differs, right? So it is the enterprise that need to look at like what they exactly are looking for, and mostly they will lie in this bucket. So the service providers can provision the network as per their requirements, right? I hope this is clear. And now let's move to our next topic, which is like the spectrum strategy. Is there a spectrum strategy that can like that matters in the 5G deployments? So in the 5G, as we know that there is a wide spectrum range that is available, right? So this spectrum range, and I will show you by the way what that range is, so don't worry. It was actually covered in some previous nuggets also, but I will show you here as well. But at a high level, private 5G, or sorry, not private 5G, the 5G spectrum range is divided into these three ranges: lower band, mid band, and high band, right? So how does this matters? How does it matter for an enterprise? How does it matter for a service provider, right? Being a network engineer, what we look at is the two aspects basically. One is coverage, right? Another one is the throughput, or let's say bandwidth, right? How much bandwidth I'm getting, how much the coverage I'm getting. So if there is a lower band or FR1 segment, which is anywhere like below 1 gigahertz, right, of the spectrum, basically you get more coverage, right? So this denotes this. You get more coverage, but at the same time, you get less bandwidth. Then if you come to the mid band, here comparatively to the lower band, you get less coverage, but then bandwidth is more in this segment, right? You get anywhere around 1 to 2 gig of the bandwidth in the mid band. And finally, the third range comes, which is like mm wave or fr2, which is here, where from the coverage perspective it is very less. It can even travel some meters only, and it cannot penetrate walls, rocks, or any other obstacles, but then it serves the bandwidth of 10 gig, right? Millimeter waves have that capacity to serve higher bandwidth, but your coverage will be low, right? So you see how these three ranges, let's look at it from another slide where it is more clear. So if you are talking about the lower band, which is somewhere here, right, you get somewhere around 200 mbps to 300 mbps of bandwidth, and it's somewhere around 1 gigahertz, but your range is quite high. The coverage basically is very high. This is somewhere a mid path where you get like a decent coverage, somewhere around 2 to 3 kilometers, but you get a decent bandwidth as well. And if you want to have a requirement like very high bandwidth, where somewhere around 20 gig, 10 to 20 gig, your range of spectrum should be millimeter wave spectrum, right? And then, as I was talking in one of the earlier session, different countries have taken different approaches to allocate spectrum in the private 5G deployments. And I see that some of the countries have even allocated spectrum in the millimeter wave segment as well. So the point here is, again, the key takeaway here is, if there is a more coverage, then there will be lesser bandwidth. If there is a more capacity, the coverage will be less. Right? So again, going back to our previous point, 5G outcome will depend on the spectrum. Okay, and this is actually the numbers that you see below 1 gigahertz, which is your lower band, FR1. Wide coverage, excellent building penetration, it can even penetrate rocks also, right? But if you see the bandwidth, right, by now you know that it will be less, somewhere around 200 to 300 mbps only, right? If it is a mid band, somewhere around 1 to 6 gigahertz of the spectrum, good coverage, but a decent bandwidth, 1 to 2 gbps, right? But if it is a millimeter wave segment for 5G, right, range is low, but it supports lots and lots and lots of bandwidth, right? So even as you see, your spectrum strategy also have an impact on the 5G outcome, right? So to reiterate, the key takeaway for this session is that not all the 5G system or not all the spectrums have the same objective. It depends on what type of use case you have, and then they can have a different deployment strategy. It actually depends on the use cases. So I hope with this session I was able to break the myth for these business leaders or my beginner friends that 5G is actually not that silver bullet which can solve everything. It depends on the use cases what you are targeting for, and then go with the deployment. So I hope this session was informative for you, and I would like to say thanks a lot for viewing this.